Hey students, let's get started on our next assignment. This is 8th grade math, unit 1, lesson 9, and the title is Moves in Parallel. But first, we're going to talk about vertical angles. Let me spell that. Vertical angles. Can you guess what that is? Look at these two lines and where they intersect. The angles across from each other are vertical angles. Let me draw that a little better. Okay, ABE and angle CBD are vertical angles. They are across from each other at an intersection. Where two lines intersect, you get 4 vertical angles. The purple pair, these are vertical angles, and the green pair, those are vertical angles. Okay, let's start our work. The first question asks, what is the measurement of angle ABC? And this M right here, it means measurement. Measurement of angle ABC. Okay, I'm just gonna draw that angle here so we all see it. What is the measurement of angle ABC? Well, to find this, look for straight lines. Here is a straight line, and you know that a straight line has 180 degrees. So, if this angle here is 50 degrees, then you know angle ABC must be 180 minus 50 degrees. So let me write that. 180 degrees minus 50 degrees. Does that make sense to you? This whole thing is 80 degrees. So take 180 and minus 50 degrees. The answer is 180 minus 50 equals 130 degrees. So this section here is 130 degrees. I'm going to write that just a little bit neater. Okay, remember this is 50 degrees. Here's a straight line. This is a half circle, so that is 180 degrees. Always remember that a straight line is 180 degrees. So then subtract 50 from 180 degrees, and you get 130 degrees. 130 degrees plus 50 degrees equals 180 degrees. Okay, type your answer here on the line, 130 degrees. Okay, keep going. The next question asks, what is the measurement of angle ABE? ABE. Okay, well, hold on. We just calculated that this angle is 130 degrees, right? And now let's look for another straight line to help us. EBC is a straight line, so we know that is 180 degrees. So this section of the angle and this section, they must equal 180 degrees. So what plus 130 equals 180? Well, let's actually look at that differently. 180 minus 130 degrees equals what? 50 degrees. Good job. You got it? So let me write that in here. 50 degrees. Whoa, we just discovered that vertical angles are congruent. They have the same measurement. This angle is 50 degrees and its vertical angle is 50 degrees. So please remember, vertical angles have the same measurement. Let me draw that a little cleaner to help you remember. vertical angles have the same measurement. In this picture, these two vertical angles are 50 degrees. They are congruent. That means the same measurement. They are congruent. Vertical angles are congruent. They have the same measurement. Okay, type your answer here on the line, 50 degrees. Let's go to the next problem. What is the measurement of angle EBD? EBD is here. Okay, well, you know what we calculated so far, right? It told us that this is 50 degrees, and we calculated that this angle is 130 degrees, and then we calculated that this congruent angle is 50 degrees. So what about this remaining angle? Well, look again for a straight line, because a straight line has 180 degrees. So this whole thing is 180 degrees. That means this angle is 180 degrees minus 50. Let me write that down. A little neater there. There we go. 180 degrees minus 50 degrees equals 130 degrees. We discovered another set of vertical angles. Let me show you them in a brighter color. We have discovered another set of vertical colors. Here and here. Here and here. These are vertical angles, and they are congruent. They have the same measurement, 130 degrees and 130 degrees. So, when you have two intersecting lines, then there are two sets of vertical angles. These angles are vertical angles, and they are congruent. That means the angle measurement is the same. They sit across from each other, vertical angles. And the other set of vertical angles is here. They are across from each other. They have the same measurement, vertical angles. Okay, you got it. So put your answer here on the line. The measurement of angle EBD is 130 degrees. Let's keep going. Read the directions carefully. Points P and Q are plotted on a line. Okay, here's points P and Q, and they are plotted on this line. Good. Move point R so that a 180 degree rotation with center R sends P to Q and Q to P. So we want P to move over to Q and Q to move over to P after a 180 degree rotation. Okay, well, we already learned what happens when you rotate a line segment or a line. Do you remember very well? Let me remind you. Okay, if we have a line segment or a line, and we rotate by a point on the line segment, 180 degrees, then the line segment stays in line with the original line segment. The image is in line with the original line segment. If we rotate by a point off the line segment, 180 degrees, then this point here is going to go here, and this point here is going to go here, and we get the image is over there. It kind of looks like a reflection. And then if we rotate a line segment 180 degrees by a point on the line, let me erase this other stuff. So now the point is on the line. What happens? Well, if this is line segment A, and this is not line segment, I'm sorry, point A, and this is point B, and you rotate 180 degrees, then A moves to the other end point. This becomes A prime. B moves to the other end point. This becomes B prime. A 180 degree rotation with the midpoint as the center of rotation just flips the line. Let's try it. I'll erase all my markings to clean up the screen. Okay, so let's try this. First, get the Reflect About Point tool. Click the line segment and then click the point. Ding! And type in the angle that we were told, 180 degrees. Hit OK. So first, if you have a point not on the line, then the image is somewhere on the other side of the point, like right here. As we move this point, the image becomes closer and closer. Bing! Look at that. When we are on the line, then the line is rotated right on top of itself. Now, this is a 180 degree rotation. So you know that P is going to move over here and Q is going to move over here. But the directions say we want a rotation that sends P to Q and Q to P. So where should this center point be? Right in the middle. The center point should be right in the middle. I'm going to clear the screen. And I wonder if I can put some more points on here. Nope, it didn't label them. Okay, it didn't label P and Q when I used the rotation tool, but I'm going to do it one more time. Click the line, click the center, type in the angle we were told to use, which is 180, and hit OK. Now, if I put this center point on the line here, it's not in the midpoint between P and Q, then P is going to rotate over here. This would be P prime, and Q would rotate right here, Q prime. Well, that's not what we want. We want to send P to Q and Q to P. So if I change this center point, then I can do it. So let's change the center point right here to the midpoint. There we go. Now P rotates to Q, and this becomes P prime. Q rotates here. This becomes Q prime. Okay, good job. Remember, it should be the center point of the line segment. But this GeoGebra applet doesn't label our other points, so it's a little hard to see. You need to imagine and know what you're doing. Let's keep going. Oh, I'm sorry. I forgot to type in my answer. Don't keep going till you type in your answer. It says, is there more than one point R that works? No. Only the midpoint. Only the midpoint. Let me change that. Sorry, I'm going to start typing over. So, is there more than one point that works? No. The midpoint is the only center of rotation that sends P to Q and Q to P. Okay, good. I got it now. Let's go on to the next problem. The instruction says, in the picture, triangle A prime, B prime, C prime is an image of triangle ABC after a rotation. The center of rotation is D. Okay, let me just spot that real quick. The center of rotation is D. Here is A prime, B prime, C prime. This triangle is the image. Remember, the image is what we call it after a transformation. So ABC is the original figure. That's our starting point. Okay, the question says, what is the length of side B prime, C prime? Explain how you know. B prime, C prime is here. What is the length? How do you know? Well, look at this. It is labeled on the original figure. BC equals 4 units. Well, BC and B prime are corresponding parts. The lengths and angles do not change in a rigid transformation like a rotation. So when this triangle is rotated, all of the angles and side lengths stay the same. If BC is equal to 4, then B prime C prime is also equal to 4 units. Let me type in my answer. And it says explain how you know. So let's explain that. I know that rigid transformations do not change lengths or angles. So B prime C prime equals BC, which equals 4. Please type in your answer. Look at the next problem. In the picture, triangle A prime, B prime, C prime is an image of triangle ABC after a rotation. The center of rotation is D. Okay, it's the same picture. Question, what is the measure of angle B? Explain how you know. Let me find it on the figure first, on this diagram. Here is angle B. What? Oh, I'm sorry. There is angle B prime. It's asking what is angle B. Aha, I got it now. Here is angle B. What is the measure of angle B? We can put M for measure and then angle B. What is the measure of angle B? Well, a rotation does not change the measurements of the angles. This is a rigid transformation, so corresponding parts stay the same. Angle B and angle B prime are corresponding angles. They have the same measurement after a rigid transformation. Okay, let me type in my answer. It says, what is the measure of angle B and explain how you know? Okay, ready? I know that B and B prime are corresponding angles. So they have the same measurement, which equals 52 degrees. I'm going to put in a little more. A rigid transformation does not change angle measurements. Let me say that again. I know that B and B prime are corresponding angles, so they have the same measurement, which is 52 degrees. A rigid transformation does not change angle measurements. Good job. Okay, we see the same diagram again, triangle ABC, and its image after a rotation, A prime, B prime, C prime. And the question asks, what is the measure of angle C? Explain how you know. Okay, so look, angle C prime is 50 degrees. So what is the measurement of angle C? Remember, these are corresponding angles. Just like in the last question, corresponding angles have the same measurement. A rigid transformation does not change angle measurements. So please type in your answer on this one. Think about it and remember what I said in the last problem. I said a rigid transformation does not change angle measurements. So you know that angle C after a rotation is equal to angle C prime. Okay, type in your answer. Now I'll start the next problem. Read carefully. The point -4, 1 is rotated 180 degrees counterclockwise using center 0, 0. What are the coordinates of the image? Well, we're going to have to visualize this one. Let me draw the coordinate plane. Wait, that's a little crooked. Let me fix that. Oh, you know what? I'll try to use this line here. There we go. This is the coordinate plane, and center point 0, 0 is here. It says the point -4, 1. Remember, the x value is first, followed by the y value. Okay? The y-axis is up and down. The x-axis is side by side. So -4, 1, 2, 3, 4. There's -4. And the y value is 1. So just go up 1. That means my point is right about here. Let me label that -4, 1. Now, what is the coordinate of the image after a 180-degree rotation around center point 0, 0? Think about that. Okay, so if we have a 180-degree rotation, everything completely flips. I'll just draw a straight line. That always helps me. Oh, I did a bad job drawing the straight line because I didn't go through the center point. Let me do that again. Through the center point, like that. So this is a 180-degree rotation. Remember, a straight line has 180 degrees. So if this point is going to move over here, it's still going to be 4 units away. 1, 2, 3, 4. And instead of being 1 unit up, it's going to be 1 unit down. So it really should be right there. The reason why it's not on my line is because I didn't draw my line straight. So this is 4 units across, and this is 1 unit down. We'll call that -1. So what are the coordinates of this point? The coordinates of this point are x equals 4, y equals -1. The original coordinates were -4, 1, and the image is 4, -1. So look at that. We went from this point here to the image here. That is a 180-degree rotation. The x-coordinate changed signs from negative to positive, and the y-coordinate changed signs from positive to negative. Okay, check your answer here. Please select the correct answer. It is x equals 4 and y equals -1. Read it carefully. See you later, guys. Bye-bye.